welcome you to this virtual class brought to you by Wisdom 360. We are into the second chapter of physics, right? We have done the first one, and now we are starting the second chapter, motion in one dimension, right? If you have any issues in the first chapter, though we have done it very thoroughly, I've given you the virtual vernier calipers and screw gauge also. You must have tried it, right? So if you have any issues, you can still write to me. And today we start with the second chapter. Okay. So in this chapter, first of all, we have already done what are physical quantities in the first chapter, right? Quantities which can be measured. Okay. The first chapter was measurement and experimentation. So we started by understanding what are physical quantities. Quantities which can be measured are known as physical quantities. So now, okay, no issues. Shubhi says she has understood everything. Wonderful, Shubhi. Okay, so we start today by understanding now physical quantities are of two types. They are known as scalars and vectors. We had done a little bit of discussion when we did the first chapter. Now we do a little thorough discussion about it. What are scalars and vectors? Many children, this is the first part of the second chapter. Many children, they don't understand. They keep on wondering. Today I was Googling and I saw that one of the most frequently asked questions is, what is magnitude? Which means most of the children, they don't understand what is magnitude. So we will understand it today. Okay. Here we start with scalars and vector quantities. There are two types of physical quantities. One is scalar, the other one is vectors. We start by understanding what are scalars. Scalar quantities are also known as scalars. Okay, these are the physical quantities which are expressed only by their magnitude. Most of the teachers will tell this, direction is not required, you only need magnitude, and they go forward. And then the kids keep on wondering what actually magnitude is. Okay, and so one of the most often asked Google questions is, what is magnitude? We'll answer that today. Okay, we take example. I take that a scalar quantity is mass. Okay, I say that the mass of a certain object is 50 kgs, and that gives me complete information. I don't need any other information. You must have never seen anybody saying, okay, you must have never seen anybody saying that the mass of a certain object is 50 kgs east, 50 kgs north. No, that is, no, it sounds a little bit, we are not familiar with such type of things. It's not common, okay? We don't use that. We don't use direction in scalar quantities, okay? So what is magnitude? Magnitude is the numerical value. Now you see, I need just two things. To tell me about a scalar quantity. One is the numerical value, and the second thing which I need is the unit, appropriate unit which I have chosen. Okay, so when I'm measuring mass, it's a huge mass, so I have chosen kg. I have chosen the unit, I chose kg. Now I compare it, that as compared to a standard kilogram, this mass, how is it equivalent to that standard quantity? And I see that this mass is 50 times that standard quantity. Okay, so I write 50 kgs, which means the mass of this object is 50 times the standard unit, a kg. I have chosen a unit, the appropriate unit kg, and then I've compared it. On comparing, I find that this mass is 50 times that mass, the standard mass. Okay, so this 50 kg is known as the magnitude. It is telling me two things. It is telling me which quantity have I compared it with, the standard quantity, which standard quantity have I compared it with, and then it also tells me how many times this mass is compared to as the SI unit of mass. Clear? So most students, they keep on wondering what is magnitude, what is magnitude. I am sure you must have understood. Good evening, Janvi, you are late. You didn't leave the previous class? You are enjoying there? Okay, welcome. We haven't discussed much, Janvi. We just discussed what are scalars and vectors. Okay, and we answered one most frequently asked questions. मोस्ट किड्स कीप ऑन वंडरिंग, यार ये सब मैग्नीट्यूड बोलते हैं कि इसमें केवल मैग्नीट्यूड डायरेक्शन नहीं, आखिर ये मैग्नीट्यूड होता क्या है? इट ऑल्सो सीम्स लाइक अ वेरी हेवी वर्ड है ना, मैग्नीट्यूड, मैग्नस वर्ड, अ बिग वर्ड. इट्स अ वेरी सिंपल वर्ड. सिंपल दो चीजें इसमें पता लगती हैं. एक तो किस स्टैंडर्ड क्वांटिटी के साथ उसका कंपैरिजन किया है, दूसरा कंपैरिजन किया तो वो उस स्टैंडर्ड क्वांटिटी के कितने गुना है, हाउ मेनी टाइम्स इज इट. So 50 kg gives me complete information. I don't need any direction for this. Understood? So you must have read whatever is written. I can read it out once again, okay? So what do we need to express a scalar quantity? We need a numerical value which represents the number of times the unit is contained. And number two, I have to follow it by an appropriate unit which I have chosen for measuring it. Done? Very nice. Wonderful. Shubhi says physical quantity is equal to numeral value into unit. Wonderful. So this comes from the first chapter, right? Which means, Shubhi, you have done the first chapter nicely. Unit is a standard reference. See, there we go back to the first chapter. Good job, Shubhi. Okay. So now that we have understood, we take some examples. Okay. Examples of scalar. One we have already taken, mass. Okay. Second, I take length. So what do we express length in? Quickly punch in, Shubhi and Janvi. If I have to measure length, what do I measure length in? What unit do I choose? What unit do I choose? In India, generally, what is the unit which we choose? You want to answer? Okay. Now, 3 seconds. 1, 2, 3. And the answer hasn't come. So I give you the answer. It takes some time, for the video to reach you and then for you to type and then for it to come to me. Still waiting. I thought that Shubhi is going to answer. So Shubhi doesn't answer. So I tell you now. I give away, okay? I measure the length. In India, we measure it in feet. और बहुत लंबा है रे, 6 फुट का है. He is 6 feet tall. Okay, or they say that if we measure it in meter standards, when these days they do the physical testing in the school, right? So measure your height, and there they write that this boy is 1.82 meters tall. Okay, so they don't say he is 1.82 meters north tall. They don't do that. They don't give you direction. 1.8 meters is complete in itself. 6 feet or 5 feet 11 inches is complete in itself. Okay? Feet. Janvi now gives the answer. Feet. So Janvi, you're correct. Feet. In India, we generally wear it in, measure it in feet. 5 फुट 11 इंच लंबा है. ये लड़की 5 फुट बहुत लंबी है. 5 फुट 8 इंच लंबी है. दीपिका पादुकोण, tallest heroine. Shilpa Shetty was one of them. Okay? So in India, we measure it in feet. And standardly, there Shubhi gives it. We measure it in meter. In school, if they do your physical test, they measure it in meters. Right? So I don't need direction, and hence it is a scalar or a scalar quantity. Okay? Next, we measure time. What's the time? 45 minutes past 6. Past, that's it. 45 minutes past 6 east. West, no, meaningless. That's meaningless. We don't need that. We don't need direction. So again, time is a scalar quantity. Time goes one way only. कभी time उल्टा नहीं चलता है. Time machines की हमने कहानियां सुनी हैं, novels पढ़े हैं, पर पीछे कोई गया नहीं. हमने नहीं देखा भाई, फिजिक्स वाले नहीं मानते ये सब. We'll make a machine someday. Okay, but at present we believe that time goes only one way. It goes forward. समय आगे बढ़ता जाता है. समय बहुत जरूरी है भैया. नुकसान नहीं करिए समय का. अभी समय मिला है, पढ़िए, खराब मत करिए. Right? So time also is scalar. Next we go to distance. Okay, sir, it takes time. What? Yeah, I know. I know it takes time. Don't worry. That's why I wait also. That's why I wait also for you to answer. Okay. Next, we go to, what did I say? Next, we take example of distance. Distance we are going to study in this chapter. Okay. So, I come to Shubhi's house. Okay. These days we have barricades. Bamboos बांध के ना हमारे पूरे मोहल्ले को सील कर दिया. तो we are not able to take the normal way. So I just hunt for ways कि किधर से मोहल्ले से बाहर निकलने का रास्ता खुला है. So what is happening? I take any route. I start from here, I turn there, go there, then again come here, and then finally arrive here. Okay. So how much distance have I traveled? Suppose this is 3 kilometers. Okay. So मैंने 3 किलोमीटर डिस्टेंस कवर करा, टेढ़ा मेढ़ा घूम फिर के तेरे घर गया. 3 किलोमीटर तुम्हारा घर मेरे घर से है. Okay, that makes complete sense. I don't need anything else. So distance is a scalar quantity. Alright, next we take volume. हमें दिन में कम से कम 2 लीटर पानी पीना चाहिए. Okay, summers आ गई हैं तो 4 लीटर पियो. Why? Because you will perspire a lot. I have given the volume. I don't say 4 liter east पानी पियो या 4 liter north पानी पियो. No direction required here. 4 liters is complete in itself. So volume is a scalar quantity, right? Then we say आजकल गर्मी बहुत बढ़ गई है भैया. दिन का तापमान 37 डिग्री के आसपास पहुंच गया है. 37 degrees Celsius is the highest temperature being recorded these days. Okay, so 37 degrees Celsius is complete. I have chosen the unit degree Celsius. 37 is the numeral value. Okay, so that gives me complete information. Temperature is scalar. I don't need distance over here. Okay, then work. Okay, how much work I have done. Okay, work we get by multiplying force, which is a vector quantity, and displacement, which again is a vector quantity. But work is a scalar quantity. It is a dot product of two vectors. We call it it is expressed in SI unit joules, and I don't need direction for it. Okay, the force could be in a different direction and the work done could be in a different direction. So we take work as a scalar quantity. I hope I have given you enough examples, right? I hope I have given you enough examples. We move on now. We move on to vectors, okay? Let me erase all this. And we move on to vectors. Understood everything, girls? Give me a yes. Now you're getting time to reply. Okay, now we go to vector quantities.
Yes.
Okay, very nice. Okay, now we go to vector quantities. Okay, in vector quantities, I need both. I need magnitude. Okay, which means I cut it from here. Which means I need the numerical value. Okay, which means I need the unit, appropriate unit with which we make the comparison, and we also need direction. We also need direction. Okay, so we need three things. These two form the magnitude, and then I need direction also. I need both magnitude as well as direction to fully define a vector quantity. Okay, now let me show it you by an example. Okay, now I have a door over here. There's a door and it is closed at present. Okay, I have the hinges over here. I have the hinges over here. I've got a handle over here. Okay, now my friend tells me कि मेरे घर आओगे ना तो हम दरवाजा बंद नहीं करते भैया, ठीक है, आ जाना, डिस्टर्ब नहीं करना, हम काम कर रहे होंगे, आके ना तुम बस फोर्स लगा देना 5 न्यूटन का और तुम हमारे पास पहुंच जाओगे. And I come and I push it. I push it with a force of 5 Newton. Okay, I'm pushing it and it is not opening. I apply a larger force, 10 Newton, still not opening. Okay, भैया क्या हो गया, झूठ बोला था क्या? Okay, and now he comes from behind. He says, अरे हम तो घर में थे ही नहीं, ठीक है, तुम क्या कर रहे थे? मैं कहा तुमने बोला था भाई 5 न्यूटन का फोर्स लगाना, हमने तो 10 न्यूटन लगा दिया तब भी नहीं खोल रहा. हट. He holds the door like this and pulls. He said, देखो बोला था ना 5 न्यूटन में आराम से खुल जाएगा. Now what happened when he applies the force? The direction changes. Okay, now he pulls it 5 Newton. I was applying the force in a different direction. I was pushing it, and now he pulls it. So the direction changes, and the work done by the force changes, right? So now for force to be defined, I have to define the direction also. Without direction, it is incomplete. Only if I say 5 newtons, okay, which is only the magnitude, okay, then it is incomplete. Okay, 5, something she writes, what does she write? In which magnitude as well as, yeah, correct, Shubhi, smart girl. My girl is very smart. Okay, so in this yeah, example, velocity also very nice. We'll be studying distance, displacement, one is scalar, one is vector pair. Then we'll be studying speed, velocity, again one is scalar, one is vector pair. So if you know about them, you've studied in class 8 also, that's wonderful. Okay, now let's see what else. Okay, now examples of this, I've given you 2, displacement, I have given you velocity, I have given you example of acceleration. Then there is momentum, mass into velocity. Okay, then force, I have already given you the example. Then moment of force, if a body is pivoted, okay, if a body is free to move, when I apply a force, it moves in the direction of the force, right? So again I said force is important, it's a vector quantity. Without direction, it's incomplete. So when I apply a force, if the body is not pivoted, it moves in the direction of the force. But suppose the body is pivoted means it is pinned. Okay, now I have a rod like this, okay, and I pin it over here, I pin it, okay, which means I nail it. Now when I apply a force, is it going to move in a straight line? No, it cannot, because it is pivoted, it is pinned over here. So what happens to it? Now it starts going in circles about the axis of rotation, about the pivot. Got it? So now you can see that this is clockwise. This is clockwise. On the other hand, if I apply the force over here, I am not changing the direction of the force, mind you. The force is upwards here also, and the force is upwards there also. And now the rod starts going anti-clockwise. Now it is going anti-clockwise. Got it? So I change the point of application, and you see that the body starts rotating in a different direction. Now to find out this, we use something known as moment of force. Got it? So again you can see moment of force here was clockwise, and there it is anti-clockwise. So moment of force also is a vector quantity. We have to tell clockwise or anti-clockwise. So anything which is incomplete without its direction is known as a vector quantity. Vector quantity is something in which I not only need its magnitude, but I also need to know its direction. Only then its meaning is complete. Right, girls? Okay, we move forward. So we have taken many examples. We have understood scalar, we have understood vector, and now it is time for us to move forward. We go now to, what do we have next? We have rest and motion. 2.2 is rest and motion. Okay, now motion also is relative. Relative means I have to first choose a reference point. Okay, now based on the reference point, I can tell whether the body is in motion or not. Okay, if you look at your walls, the walls of your room, of your house, okay, are they in motion? Right? Are they in motion? Okay. Most kids will say that they are not in motion. And you're right. Why they are not in motion? Because you are sitting here and the walls don't move. They are at the same position with the passage of time. It's not that the walls come closer to you or the walls go further away from you. So we have chosen ourselves as the reference point. A table of the room are the reference point, and those walls don't change position, okay, with the immediate surroundings. So they are stationary. Okay. On the other hand, if I go into space now and I'm watching the earth from there, and then I see the earth is rotating and revolving also, and your house also is rotating and revolving along with the earth. Okay, so now the reference point has changed. Got it? So now we simply understand what is rest and motion by taking the example which is given in your book of a station. Okay, I have the platform of a station, I have the railway track over here, okay, and there's a bench over here, and you are sitting on the bench. Okay, you are sitting on the bench. On the platform you have a tree also. Okay, now when you look at the tree is not moving. Okay, if I take the reference point as the bench, the tree remains in that same position with the passage of time. It does not change its position. Okay, this tree is not changing its position with its immediate surroundings, so it is at rest, it is stationary. Okay, or if I take a stone over here, a stone lying on the platform, the stone is not changing its position with its immediate surroundings, so it is at rest. Okay, and now the train comes, okay, and it goes away. Now the train comes and it goes away. Got it? You can see that the train is changing its position. It was here, after some time it's here, and now it is gone. Okay, so the train is changing its position with its immediate surrounding, so it is said to be in motion. Okay, let me read quickly what is given in your book. Okay, a body is said to be at rest if it does not change its position with respect to its immediate surroundings, while a body is said to be in motion if it changes its position with respect to its immediate surroundings. So they are talking about immediate surroundings, so we focus on the immediate surroundings. Okay, so this stone is not changing its positions with respect to immediate surroundings, with a tree, with a bench. Okay, but this train is changing its position with respect to its immediate surrounding. So this stone is at rest. Okay, this stone is at rest, and this train is in motion because it is changing its position with respect to its surrounding, immediate surrounding. Clear? No issue? Very simple thing to understand. Anything else is given? No, nothing. Okay, next we go to one dimensional. Okay, I erase all this. We go to the next topic. It was easy, girls. Understood? Next we go to 2.3, right? 2. No, it's a part of 2.2 only. One dimensional motion. Okay. Okay, what is one dimensional motion? One dimensional means only in one dimension. You have understood one dimension, two dimension, three dimension, right? If we take only one variable, then if we take only the x-axis, then it is one dimension. If we take two coordinates, okay, the x and the y, then it becomes two dimensional. If we take the three axes, x, y, and z, then it becomes three dimensional. Got it? So if a body is moving in a straight path, okay, if a body is moving in a straight path, okay, for example, we take the example of a stone falling. This was a building, okay, this was a building, and I drop a stone from top of the building, so the stone goes down straight. Okay, a car is traveling on a highway. Okay, a car is traveling on a highway which is straight, okay, without any turns, then this is one dimensional motion. Okay, so if a body is traveling in a straight path, we call it one dimensional motion, or we also call it rectilinear motion. Right, very simple. If a body is traveling in a straight path, we call it one dimensional motion or rectilinear motion. How do we represent it? I already told you, I need only the x-axis. Okay, representing it on a vertical axis becomes a bit cumbersome. Okay, you keep on going up, so we take a horizontal axis, and the horizontal axis is the x-axis. Okay, if this is 0, this is 1, 2, 3. Okay, oops, this is 1, 2, 3, 4. Okay, so if I say that after the first second the car has traveled 5 meters. So this is 1. Okay, I take an axis parallel to the x-axis. This is 5. Then it travels 10. Then it travels 15 meters. So it is traveling uniformly, covering equal distance in every second. After every second, it has covered 5 meters. Got it? So this is how we can represent it. We can tabulate it also. We can draw a table, okay? And on one we take time in seconds, in the other we take distance in meters, okay? So after the first second, after the second second, after the third second, after the first second it has covered 5 meters, then 10 meters, then 15 meters. So this is how we can tabulate it. It's very simple. You draw a horizontal line, take to scale any measurement, and then as per the scale, you can represent the distance covered every in unit time on that axis, on that horizontal axis, right? So I hope you must have understood rectilinear motion. What all is given in your book? Rectilinear motion. Okay, this is the example given. Representation, we have done the representation. Okay, tabulation we have done. Nice. So we have completed one-dimensional motion. We have understood scalar and vector. We have understood rest and motion. Okay. Now it's 5:05. This is the last topic we'll be taking for the day, and I'll be talking about now distance. This is 2.3. 2.3. We'll be talking about distance and displacement. Okay. Now this is a scalar vector pair. I've already told you. One is scalar. Shiv Kumar. Rest means no movement and motion means movement. Very nice. Shiv. Rest means that the body is not changing its position with respect to its immediate surrounding, and motion means that the body's position is changing with the passage of time. जैसे जैसे समय बीत रहा है, समय एक ही तरफ चलता है, बढ़ता जाता है, जैसे जैसे समय बढ़ रहा है, वैसे वैसे उसकी position change हो रही है, right? Okay. Now I take a line. Okay. I said I represent one-dimensional motion on a horizontal axis, so I take the horizontal axis. Okay, this is 1, this is 2, this is 3, this is 4, this is 5, and this side I have -1, -2, -3, -4. Okay, now I say I have a ball. This is a table, okay, or a groove. एक groove है जिसमें कि छर्रा इधर से उधर जा सकता है. तो मेरा जो छर्रा था, मार्बल था, ओके, मैं मार्बल को किक करता हूँ, and it goes up to here. Okay, it comes over here, and now I kick it back. Okay, and now it comes and stops here. Okay, and then I again hit it, and now it comes and stops over here. Okay, so I ask, what is now this? Each one of them is meter. Okay, each one of them is meters. This is meters. Okay, so I now ask you, what is the distance covered by this marble? What is the distance covered by this marble? Okay, so the distance covered, you can tell me. I'm waiting for your answers. Till then I write it down. Okay, the distance, let me name it. We start from A and B, then this is C, and this is finally D. Okay, distance is the total length of the path covered. Okay, so in this case it becomes AB plus BC plus CD, which is equal to 4 plus 1, 2, 3, 3 plus 1, 2, 3, 4 plus 4 is equal to 11 meters. Any answers? No, we don't get any answers. Okay, so now you must have understood. Okay, we said that distance is scalar. Distance is scalar, which means for me the plus or minus sign is not having any meaning over here. It doesn't have any meaning. I said I don't need direction for scalar quantities. I don't need for me to. I'm only interested in the magnitude, not in the direction. Okay, so distance is a scalar quantity, and the minus sign has no meaning for me. Okay, at present the minus sign has no meaning for me, so I just have to know how many meters did it travel. So when it started from A, okay, it traveled 1 meter, 2 meter, 3 meter and 4 meters. So AB is 4 meters. Okay, and then when it was pushed back from there, then it again traveled 1 meter, 2 meter and 3 meters. So it comes back 3 meters. The sign has no meaning over here because it is a scalar quantity. And then finally again it traveled 1, 2, 3 and 4. So again 4 meters. So what is the total length of the path which it followed? It is 11 meters, right? On the other hand, if I ask you what is the displacement which the body has done, okay, so now displacement is equal to the final position minus the initial position. Got it? So what is the final position? Now the sign has meaning. Shiv Kumar, Shubhi, you changed your profile or what? Okay, chalo. You didn't reply. You were changing your mobile or what? Okay. Now when I come to displacement, for complete meaning, I not only need the magnitude, I need the direction also. Okay, so displacement is the shortest distance between the final position and the initial position. Okay, so this is the final position and this was the initial position. It had started from here and it ended up over here. Okay, so xf minus xi, okay, the final position on the horizontal axis minus the initial position on the horizontal axis, which means this is equal to the final position is minus 3 and initial was minus 3. So my displacement is negative 3 meters. My displacement is negative 3 meters, which means the body has gone in a direction opposite to where it had initially started. पहले वो उधर जाने लगी, हमने उधर प्लस लिया और उसकी जो फाइनल पोजीशन है वो उसकी ओरिजिनल पोजीशन इनिशियल पोजीशन के उल्टे है. That's why we are getting the negative sign. The negative sign here is giving us the direction. वो हमें दिखा रही है कि बॉडी जिस तरफ को स्टार्ट हुई थी उसकी उल्टी तरफ चली गई है. ठीक है, मतलब वापस लौटी और लौट के उल्टी तरफ चली गई. सो इट इज -3. इफ यू एड अप एल्जेब्रिकली, अगर हम एल्जेब्रिकली इसको एड अप करके देखें, ओके, तो दिस इज +4, ओके, देन दिस इज -3, okay, and this is -4. So +4 -4 cancels. I am still left with 3 meters. Okay, so अगर मैं सबको with the correct signs algebraically जोड़ता हूँ तब भी मुझे वही मिलता है. But the rule is the final position minus the initial position gives me the negative signs, tells me the direction. So this is a vector quantity. The displacement is a vector quantity which is complete only when I specify its direction also. Yes, Shubhi, displacement is the shortest distance. Right, we'll take one more example to understand this. In the meantime, let me have a look. Anything else? Okay, we have the differences there. Okay, I'll take the figure which is given in your book to explain it to you. You have understood all this, Shubhi and Janvi? Janvi, you're very quiet. What happened? Not speaking anything? And others, you don't even send a comment. I can see many of them. How many there? And okay, you're not giving any comments. 9 of them are watching and no comments. Okay. Now I say, suppose a body starts, the figure which is given in your book, okay? The body starts from A and it goes like this up to B. Okay, then this, the black line gives you the distance. Okay, I can measure this length. How can I measure this length? How can I measure this length? Come on, shoot quickly. Okay, I'll wait for this answer. How can I measure this length? You have to punch in there. Till then I draw. Okay, so this actual length in whichever unit, suppose I choose the unit meters. Okay, so this actual length in x meters, okay, is the distance which the body has covered. But if I draw a straight line, the scale gone. Well, I draw it like this. Okay, if I draw a straight line like this, then this blue line is the shortest distance from the initial position to the final position. The difference between the final and the initial. Okay, and suppose this is y meters. Then this y meters. Now I take the scale. Okay, this is, oops, this is north, this is south, this is east, this is west. So the body has gone like this, which means it has gone northeast. So my displacement is y meters northeast. Okay, I represent it by a S and an arrow. A vector quantity has a arrow on its head, showing that it's a vector quantity. On the other hand, my distance S is equal to x meters. Now you can see that the difference is here the direction is missing, here the arrow is missing. Okay, so I represent a vector quantity with the English alphabet, and minus 3 meters should be no, should be over here, this distance. How do I measure it? Okay, I'll tell you. We measure it using a meter tape. What I can do is I can take a rope like this. Okay, I can curl the rope in the pathway, and then I stretch the rope and I measure its length. So I get the length. Got it? Which one is greater now? Which one is greater? The distance is greater or the displacement is greater? Which one is greater? We got 4 minutes more. Jaldi se batao. Which one is greater? The distance is greater or the displacement is greater? I'll till then take you to the next one. Which one is greater? The distance or the displacement? S, yeah, S with the arrowhead. Which one is greater? Very nice. Meera. Meera says, Meera, you're Meera only na? Ki koi aur ho? Mummy ka to nahi hai ye ID. Okay. Meera says distance, and she is right. You can see that also, that the black line is longer. Got it? The black line is longer, which means that the distance is greater. Okay, we take one more example. Okay, now I again have the horizontal axis. Okay, and I start from this is O. Okay, and the body goes, okay, and I start from here and I stop over here. Okay, each one of them is 1 meters. 1, 2, 3, 4, 5, 6. Okay, in meters. Each one of them is 6 meters. So now what is the displacement and what is the distance covered? Quickly, what is the distance? This is A, this is B. What is the displacement and what is the distance covered in this case? Punch in quickly. It takes just 6 seconds for my voice and video to reach you. So it should take another 6 seconds, which means 12 seconds. Okay, so in 12 seconds, it should come back to me. Waiting. What is the distance covered here and what is the displacement over here? More? No, it is not more, Shubhi. No, it is not more. Okay, I'll tell you. In the previous case, the distance was greater, okay, than the displacement. Okay, the distance was greater than the displacement. In this case, my distance covered is 6 meters and my displacement also is 6 meters. Both are same. Okay, the body started from here, it continued in a straight path in a rectilinear motion, and it stopped over there. So the distance covered is 6 meters. Okay, it doesn't come back, so the displacement also is the same. Okay, so if the body, yes, now Mira says 6 meters, correct, both are 6 meters. Okay, so if the body travels in a straight path, then the displacement and distance are the same. Okay, so we have two cases. In one distance is greater than displacement, and in other the distance and displacement are same. They ask you this question, okay, give us a condition in which the distance and the displacement covered are the same. Then you have to write that if a body is traveling in a straight path showing rectilinear motion, then the distance covered and the displacement will be the same. Otherwise, it will always be less. It will always be less. Can the displacement ever be more than the distance? Give me yes or no. Till then I draw the figure. The question is, can the displacement ever be more than the distance covered? क्या डिस्प्लेसमेंट कभी डिस्टेंस से ज्यादा भी हो सकता है? Yes, no. No, says Meera. And Shubhi, I don't know what has happened to you today. Today you're not answering. And don't worry, chalo. Once I have done this, you study and you can answer in the next class. Okay. Now, and Meera, you are right. Meera gives the right answer that displacement can never be more than distance covered, which means displacement is less than equal to. Displacement is less than equal to the distance covered. It is always less than. या तो वो बराबर होगा अगर स्ट्रेट लाइन में है, otherwise generally वो उससे कम होगा. Right? Now we go to the last thing of the time is already up, but I'll take just 1 minute to wind it up. Okay? अब मैं एक केस ले रहा हूं जिसमें एक एथलीट ए से शुरू करता है और एक पूरे सर्कुलर ट्रैक का चक्कर लेके वापस वहीं पे फिनिश करता है. Okay? So now what is the distance and what is the displacement done by him? अगर उस ट्रैक का ये रेडियस जो था ये r था, what is the distance covered by him and what is his displacement? This is the last question of the day. We wind up after this. Waiting for your answers. My time is already up. Your next teacher must be waiting. I'm 2 minutes over my time. जल्दी से जवाब दो. जल्दी. वेटिंग. 12 सेकेंड हो गए, जवाब आ भी गया. ओके. नाउ मीरा सेज डिस्प्लेसमेंट इज 0. वेरी नाइस. अब मुझे ये भी लिख के भेजो मीरा की डिस्टेंस कितना है. बिकॉज सी ही स्टार्ट्स फ्रॉम हियर, which means this is the initial position, and he finishes here, which means this is the final position. Okay, so the difference is 0. Okay, तो उसका डिस्प्लेसमेंट जो है वो 0 है. अगर बॉडी जहां से शुरू करती है वहीं पे वापस आ जाती है. मैं सुबह घर से स्कूल जाता हूं और शाम को स्कूल से घर वापस आ जाता हूं. अब मेरा डिस्प्लेसमेंट कितना है? मेरा डिस्प्लेसमेंट 0 है, बिकॉज माई इनिशियल पोजिशन एंड माई फाइनल पोजिशन are the same. And Meera again punches in the answer. The distance is 2 pi r. Wonderful, Meera. Okay. Distance उसने कितना कवर किया? Distance उसने कवर किया जितना की circumference है इस circular track का. Okay. हमने बोला उसका रेडियस आया है, circumference का फॉर्मूला है 2 pi r. तो उसने distance कवर करा 2 pi r. अब एक क्वेश्चन ये एग्जाम में अक्सर आता है कि can the displacement be 0? Even if the distance covered is not 0. तो ये आपके पास ऑप्शन है. Yes, it can be. Circular track दिखा देना. Okay, in this case the distance covered is equal to the circumference of the circular track, which means 2 pi r, but the displacement is 0 because the initial and the final positions are the same. ओके अब टाइम ऊपर हो गया, 1 मिनट और लगाऊंगा, ठीक है। अब अगर मीरा एंड शुभी अगर वो 1.5 राउंड दौड़ता है, अब वो अगर यहाँ आके बंद कर देता है, अब अगर उसकी फाइनल पोजीशन अब अगर बी हो जाती है, तब उसका डिस्टेंस और डिस्प्लेसमेंट कितना है? 1.5 राउंड ही हैज टेकन, ओके, 1.5 राउंड लगाया है, 1.5 राउंड लगाया। अब पहले मुझे उसका डिस्प्लेसमेंट बताओ, कितना होगा उसका डिस्प्लेसमेंट? मीरा जल्दी से पंच करो। शुभी क्या हो गया है बच्ची, जवाब नहीं दे रही हो आज। ओके वी फिनिश इट ओवर यार, जल्दी से बताओ। नाउ 1.5 चक्कर लगाया, व्हाट इज द डिस्टेंस कवर्ड एंड व्हाट इज द डिस्प्लेसमेंट? What is the distance covered and what is the displacement? Displacement distance अच्छे से समझ में आ गया होगा, इसके differences एक बार पढ़ लेना, ठीक है। One is a scalar, distance is a scalar quantity, displacement is a vector quantity. Okay, we don't need to specify direction in measuring distance, we need to specify direction while measuring displacement. Distance is the actual length of the path, pi r, okay. 1.5 चक्कर लगाया शुभी, 1.5 चक्कर लगाया, you went wrong over here, okay. So एक राउंड में लगा 2 pi r, okay, और दूसरे में लगा plus half into 2 pi r, 2 cancels, okay. So it becomes how many pi r's? It becomes 3 pi r, it becomes 3 pi r, and the displacement is r plus r equal to diameter, so displacement is 2r, okay. It is buffering, okay, it is buffering, so my video is not reaching you nicely, so you are not able to make out. Don't worry, that was all for the day. I hope you have learned the differences: scalar, vector, displacement, distance, stationary and in motion. Please go through the tabular differences of all three. In the next class when I come, I take you to speed and velocity. That's all for the day. I hope you enjoyed the lecture. Please do subscribe to Wisdom 360. Please do like the videos. Tell your friends also to like them. Bye-bye. Good night.